Okay, let's take a look at the Algebra 1 quiz review for sections 1, 0 through 1, 5. That's going to include mean, median, mode, Q1, Q3, and the box and whisker plot. So if we take a look at this data, you could do it by hand by listing it in order, but since you already know how to do that, I think you should go to the calculator and go ahead and enter this data in the calculator and calculate all of those measures of central tendency. Let the calculator do the work. So we'll start by going to Stat. You can see it's on Edit, so if you just hit Enter, it will bring up your lists. If there's something in your list, you need to arrow up and clear that data from your list. And then you can begin to enter your list. So now you can enter the values given in your data set. Okay, so once you have entered all of the information into your calculator, you can go to List. Remember, if you want to, you can sort your list in ascending order by arrowing down to number 2. You hit Enter, tell the calculator where to find the data, which is that shift number 1, which is located in List 1, L1. Hit Enter. It comes back and it'll tell you that it's done. So now it's sorted in order. So if we want to go in and look at that data, we can actually now count the number of elements in the data set and then find the mode. So we're going to look for the mode here. It's 230. So we have the mode is 230. And now we're going to get the other measures of central tendency. So arrow over to calculate. The first choice is one variable statistics. That's what we're looking at. So hit Enter. You have to tell the calculator again where to look for that information, which is in List 1. You can hit Enter. So there's your one variable statistics. You can see that X bar is 234.67. You're to round to 2 decimal places. If you arrow down, it will give you the number of elements. N was 12. The minimum was 188. Q1 was 196.5. The median is 237. Q3 is 263. And the max is 283. So let's just fill that information in on our chart. Sorry, I forgot to calibrate first. I'll have to do it quickly now. Okay, so from our calculator, we know that X bar, which is the average, X bar was equal to 234.67. The median was 237. The mode was 230. Q1 was at 196.5. Q3 was at 263. If you were asked to sketch a box and whisker plot, I would expect to get something that looked similar to this and labeled the end, which was 190, the lower end, the upper end was 283. The median is 237. Sorry, that's 237. 237. Q3 was 263, and Q1 was 196.5. F says alter the data set by adding one number or deleting one number to give a median of 230. So you might want to go ahead and list these out in order then, so you can take a look what you're actually going to do to make the median 230. Okay, so if you look at this, you have 12 elements in your data set. That means that the median will be the average of element 6 and element 7, which is right here. Okay, we want the median to actually be 230, so there are actually 3 choices. One, we could add a number less than 230. We could add 230, or we could delete a number greater than 230. So any one of those would be the correct answer. Now let's take a look at the next problem. Number 2 says Sam needs a 97.5% to receive an A+ in Advanced Algebra 2. She has a 96.875% after the first 4 exams. What must she score on the 5th exam in order to have an A+? So if you think about this, you need to be a little careful with this particular problem, because the 96.875 is actually the average of her first, second, third, and fourth test. So if you're looking at finding the score for her 5th test, it actually looks like the first test plus the second plus the third plus the fourth plus what we're going to call the 5th is X. That would be over 5. And that has to be greater than or equal to a 97.5. So be careful when you're filling this in. You actually, in this equation, have to multiply both sides by 4. And then that becomes the sum of A, B, C, and D. So it actually then becomes 387.5 plus X over 5 has to be greater than or equal to 97.5. Multiply both sides by 5, subtract the 387, you will get that X has to be greater than or equal to 100. So obviously she must score 100%. So Sam needs 100% on test number 5 to obtain her 97.5% in Advanced Algebra 2. Okay, number 3 says name all the sets to which the following belong. So of course when you look at the first one, hopefully you recognize they cancel. So you just have 5. Well, 5 is a natural number. 5 is a whole number. 5 is also an integer. 5 could be written as a rational number. And 5 is also a real number. B, 1/3. That's not natural, it's not whole, it's not an integer. It is, however, a rational number and a real number. Square root of 7 is not natural, whole, integer, rational. It is irrational, and it is a real number. Pi, again, is an irrational and a real number. 0.25, okay, that's a decimal, which you could write as 1/4. That means that that is rational and real. E over E, again, that becomes 1, which is a natural number, a whole number. An integer can be written as a rational, sorry, that's a Q, can be written as a rational and a real. Okay, the next one, sorry, this goes to page 2. You have to simplify the following without a calculator, and there will be a no calculator section tomorrow on the quiz. It won't be too hard, just remember your order of operations. So when we're looking at A, order of operations with the absence of exponents and parentheses, the order of operations is left to right, multiplication and division, then addition and subtraction. Therefore, this becomes 72 divided by 12, which is 6 times 2, which is 12. That particular problem, you could have gone ahead and multiplied 72 times 2 and divided by 12, and you still would have the correct answer. That won't always be the case. Now on B, order of operations here, I have 3 plus 2. First thing I have to do is combine the 7 and the 9. That gives me 16. I can also combine the 3 and the 4, which is 12. Then I have 3. Next order is 2 times 6, which is 32, minus 12, and then just adding and subtracting from left to right, which gives me an answer of 23. C, be careful with this one. You have to first do the exponents. So I have 4 times 3 plus 16 times 5 plus 3 over 5. The next operation will be this multiplication right here. So I will have 4 times 3 plus 80 plus 3 over 5. Again, I'll do what's in the parentheses. So 3 plus 80 times 4 plus 3. So I have 4 times 83 plus 3 over 5. You'll do 4 times 83, then add the 3, and I'm just going to write the answer as 67 here because I'm kind of running out of room. D, remember to do the numerator and denominator independently. So 21 plus 9 is 30. Then 2 times 2 plus 1, which is 3. That's 30 divided by 6, which is 5. E, add what's in the parentheses first. So that's 10 squared, which is 100, divided by 25, minus 16. So that gives me 4 minus 16, which is a negative 12. F, I have 27 minus, I'll start with the 9 minus 6, which is 3, divided by 9 times 3. Oh, I'm sorry. I need to make sure my symbols of inclusion are the same. So I have 27 minus 3 over 9, which is 1/3, times 3, which becomes 27 minus 1. The answer is 26. Now let's take a look at number 5. Number 5 was a little confusing, but what it meant was that you are given sets A, B, C, D, and E, and then you're going to come down here and write the union or intersection, or union and intersection of those sets. So here, if we're looking at the union, remember the union means it's going to include all of the elements from both sets. So the union, so if I have A union, union E, that will give me the set 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to take the union of that set and intersect it with C. C is the natural numbers. So it turns out that this union of A and E intersecting C is that set 1, 2, 3, 4, 5, 6, 7, 8, and 9. In set builder notation, we will write that as X, such that X is an element of the natural numbers and X is less than or equal to 9. So that's the two representations. We have set builder notation, and we will also have roster notation. And this is roster. Roster is just listing each of the elements in that set. Okay, the next one is the intersection of B and D. B is that x is an element of the integers. It's greater than -3 and less than 3. And D has this set that is given to you. So the intersection means that it has to be in both sets. So let's take a look at what's in B. -3. Is -3 in D? No, it is not. How about this -5/2? Is that in B? No, it's not. -2, yes, -2 is in B. So -2 is in both sets. -3/2? No, it's not. How about -1? -1 is in B, it's in D. 1/2? No. And actually we can just look at this and we can say all of those fractions are gone. So we will end up with the set -2, -1, 0, 1, and 2. In set builder notation, x such that x is an element of the integers, and x has to be greater than or equal to -2, less than or equal to 2. And you can write those in words if you prefer. In fact, set builder notation tends to use more words and less notation. Finally, number C, the intersection of B and C. So if you look at the B intersect C, you'll get the set 1, 2, 3. And then the intersection of that set and E will just be the set 1, 3. Just as you would use order of operations on an equation with parentheses, you would use that same order when you're looking at combining these sets. What's in parentheses comes first. Now, using the sets from question 5, are the following true or false? Is A subset of C? Remember, in order for a set to be a subset of another set, every element in that set must be in the set you're looking at. So let's look back at A and C. So is every element from A in C? C is the set of natural numbers. We have 2, 4, 6, 8. Yes, that's true. Every element in A is in C, so that would be true. If you look at B, every element in D must be in B, and that one would be false because D contains those fractions, and B is the set of integers, which does not contain fractions. Number C, the intersection of A and E is C. That's not true because the intersection of, the union of A and E is the set from 1 to 9 inclusive, but C is all of the natural numbers. So that would be false. E is the union of A and E, a subset of C, and that would be true. Number 7 asks you to list all of the subsets of the set 6, 7, 8. So remember, all of the subsets means each element is a subset. So we have 6, 7, and 8. And then any combination, so 6 and 7, 6 and 8, and then 7 and 8. The set itself is a subset, so 6, 7, and 8. And finally, the empty set, or the null set, is also a subset of that set, 6, 7, 8. It's a subset of every set. Question number 8 asks you to write that roster notation in set builder notation. So we're going to just write that as x such that x is an element of the integers. X is greater than or equal to -6, less than or equal to 6. Could also be written as x such that x is an element of the integers. X is greater than -6 and less than 6. So you could write that either way. And as I said, set builder notation tends to have more words than notations. Number 9 asks you to write each interval of real numbers in interval notation. So we're writing the union in the first case, the union. So if we look at this on the number line, I have -2 to 6. So here's my -2, here's my 6. So this is the interval I'm referring to. And I'm going to join that with -4 and 5. So I'm looking at this interval. Remember that is the union, so I'm going to be going from -4 to 6, and that would be the union of these two intervals. So from -4 to 6. If you look at B, I'm looking for the intersection from -infinity to 1. So here's 1. So I'm looking at this region. 1 is included. And I'm intersecting that with -1 to positive infinity. So the region that they share is this region from -1 to 1. You can tell by the brackets, because it has brackets, that means that the element 1 and -1 would be included. So this interval would be from -1 to 1. Remember, the braces indicate that the element is included. Okay, the braces indicate it's included. The parentheses indicate that it is not an element in that set. Okay, from -infinity to 4, joined with -1 to 8. So if you think about that overlap, you're going to actually have from -infinity to positive infinity. So this interval is -infinity to positive infinity, so it's all the reals. Now, if you look at D, I'm looking from -4 down and 4 up. The intersection, those two intervals never intersect. Therefore, the answer to this is the empty set. The empty set. Number 10 asks you to solve the absolute value. Remember, absolute value equations you have to set up two equations. The first is 3x plus 7 equals 40. The second, because the absolute value makes it positive, that means what's inside the absolute value has the potential to be negative. So you have to take the opposite. So for the first one, I have 3x is equal to 33. So x is equal to 11. The second one, minus 3x minus 7 equals 40. Minus 3x equals 47. Sorry, that's an x. So x is equal to negative 47 thirds. Writing this in set notation, x is equal to the set minus 47 thirds and 11. Okay, the second one, I'm going to do the same thing. I have 2x minus 9 equals 51. And then the opposite of that, so minus 2x minus 9 equals 51. So 2x equals 60, so x equals 30. Minus 2x plus 9 equals 51. minus 2x equals, let's see, subtracting that, that's going to be 42. So x is equal to negative 21. Again, write that in set notation, so x is equal to the set minus 21 and 30. Number 11 asks you to state the property represented by the following equations. Here, I'm adding the opposite, so that would be the additive inverse. And you can just use this symbol to identify the operation. B is going to be the distributive property. This is the left distributive property. You will rarely use the right or left distributive property. You'll use the distributive property, but you'll rarely identify it as left or right. C will be the commutative property. Sorry about that. The commutative property of addition. D, what's changing is what we're multiplying together first. On this side, ST first. On this side, TG first. So that's going to be the associative property of multiplication. E, I'm multiplying 5x times 0. So that would be the multiplicative property of 0. And F, I'm multiplying 1 over C times C, so that's going to be the multiplicative inverse property. Multiplicative inverse property. Okay, almost finished. We want to take a look at these sets and state whether the given set is closed under the operation. If it's not, we have to give a counterexample. So we have the set A is defined to be the 4 elements root 2, root 3, root 5, root 7. The operation is multiplication. So that means I can choose any 2 elements from this set, perform the operation multiplication, and if I don't get an element in that set, then the property of closure is not true. So this is an open set because the operation generates an element that's not in the set. Okay, 13. B is defined to be the set 1/2, 1/3, 1/4, 1/5, 1/6, etc. The operation is multiplication. That means I can take any 2 elements in this set, multiply them together, and I will get an element in this set. And the answer to that is yes, that is true. This is a closed set. The property of closure is true. If you take 1/2 times 1/4, you get 1/8, and that is in our set. C is defined to be the set of even natural numbers under addition. So if you add any 2 even natural numbers, you will get an even natural number. So the answer to this, again, is yes. D is defined to be the set of odd natural numbers under addition. So if we take any 2 elements, 1 plus 3 gives me 4. 4 is not in my set, so therefore, this again is an open set. The property of closure is not true. Okay, the property of closure is not true. And that's the end of the video. I hope you study hard and you're prepared for the test tomorrow. I will see you tomorrow.